In the next exercise 1.7, we are asked to solve the equation 3x plus 2y plus 7z is equal to 0, 4x minus 3y minus 2z is equal to 0, 5x plus 9y plus 23z is equal to 0. Now to solve these homogeneous equations, let us write this in matrix form. Ax is equal to b. So now, writing the augment matrix AB is equal to 3, 2, 7, 0, 4, minus 3, minus 2, 0, 5, 9, 23, 0. Next, our aim is to write this in echelon form. So, to write this in echelon form, let us write the first row R1 as R2 minus R1, second row as R3 minus R2, third row as it is 5, 9, 23, 0. So to make this place 0, first element of the second row 0. Therefore, to write this matrix in echelon form, let us write the first row as it is 1 minus 5 minus 9 0. Second row R2 is equal to, now we are supposed to make the first element of the second row 0. So R2 is equal to R2 minus R1. So R2 minus R1. This gives you 1 minus 1 0. 12 minus of minus 5 17. 25 minus of minus 9 34. This place 0. Then next our aim is to make third row first element 0. So to make this place 0, multiply R1 by 5. You get here 5 minus 25 minus 45 and 0. So 5 minus 5 will be equal to 0. 9 minus of minus 25 will be 34. 23 plus 45 will give you 68 and this is 0. So what did you do? R3 is equal to R3 minus 5R1. Next, our aim is to make this place 0. So here, by elementary transformation, 1 minus 5 minus 9, 0, 0, 17, 34, 0. Now here R3 is equal to R3 minus 2R2. So if you multiply here by 2, you get 0, 34, 68, 0. So subtract, you get 0 minus 0, 0, 34 minus 34, 0, 68 minus 68, 0, 0 minus 0, 0. Now this is in echelon form. This is in echelon form. Therefore, rank of A is equal to rank of AB is equal to 2. See, it is in echelon form, and how many non-zero rows? Only 2 non-zero rows are there. 2 non-zero rows. Therefore, rank of A is equal to rank of AB is equal to 2, which is less than n, which is less than 3. There are 3 variables x, y, z. Therefore, this is less than 3. Hence, the equations are consistent. Consistent and has many solutions. Okay, so we are going to rewrite again in matrix form. Therefore, it is going to be 1 minus 5 minus 9, 0, 17, 34, 0, 0, 0 into x, y, z is equal to 0, 0, 0. This gives you x minus 5y minus 9z is equal to 0. 17y plus 34z is equal to 0. So here there are three variables and we have only two equations. So substitute. Z is equal to t. Therefore, 17y is equal to minus 34t. Y is equal to minus 2t. Now substitute Z is equal to t and y is equal to minus 2t in equation 1. This first equation. So we get x minus 5 into minus 2t minus 9t is equal to 0. So x plus 10t minus 9t equal to 0. X plus t is equal to 0 gives x is equal to minus t. For all values of t belongs to the set of real numbers. Therefore, for all values of t, the equation x minus 5y minus 9z is equal to 0. The given equations will have many solutions. Second question, 2x plus 3y minus z is equal to 0. X minus y minus 2z is equal to 0. 3x plus y plus 3z is equal to 0. Now, writing in matrix form. What do we get? 2, 3 minus 1, 1 minus 1 minus 2, 3, 1, 3 into x, y, z is equal to 0, 0, 0. So this is of the form Ax is equal to B. Therefore, writing in argument matrix, AB is equal to 2, 3 minus 1, 0, 1 minus 1 minus 2, 0, 3, 1, 3, 0. So to solve this equation by Gauss elimination method, we are supposed to write this in echelon form. So to write this in echelon form, let us interchange the rows. Here R1 to R1 to R2 and R2 is going to R1. So here you get 1, 1 minus 2, 0. Then 2, 3 minus 1, 0. 3, 1, 3, 0. Next, our aim is to make the first element of the second row to be 0. So if you subtract R2 minus 2 R1, so you are going to write R1 you write as it is 1, 1 minus 2, 0. R2 is equal to R2 minus 2 R1. So R2 minus 2 R1 gives you, multiply here by 2, this will be 2, this will be 2, this is minus 4 and this is 0. So 2 minus 2 gives you 0, 3 minus 2 gives you 1, minus 1 minus 4 gives you plus 3 and this is 0. Next we are supposed to cancel this place, make this place a 0. So your R3 is equal to R3 minus 3R1. So this place is 3, this is 3, 1 into 3, 3 minus 2 into 3, 6 and this is 0. So 3 minus 3 gives you 0. 1 minus 3 gives you minus 2. 3 plus 6 gives you 9. This is 0. Next our aim is to make this place a 0. So the other two rows you write as it is. So this is equivalent to 1, 1, 2 minus 2, 0. Then 0, 1, 3, 0. Now, to make here 0, multiply the second row by 2 and add, you get this place to be 0. So, your R3 is equal to R3 plus 2R2. So, if you multiply this row by 2, you get here 0, you get here 2, you get here 6, you get here 0. So, 0 plus 0 gives you 0, minus 2 plus 2 gives you 0, 1 plus 9, 6 plus 9 gives you 15, then 0 plus 0 gives you 0. So, here, till here it is A and the full thing is AB. Therefore, rank of A, see this is in echelon form. This is in echelon form. How many non-zero rows are there? There are 3 non-zero rows. As there are 3 non-zero rows, rank of A is equal to rank of AB is equal to 3, that is equal to n. Okay. Therefore, the system of equations have unique solution. Therefore, the system of equations will have unique solution. They are consistent and they have unique solution. And they are consistent. So, writing once again in matrix form, this will be equal to 1, 1 minus 2, 0, 1, 3, 0, 0, 15 into x, y, z is equal to 0, 0, 0. Now, expanding, you get x plus y minus 2z is equal to 0, y minus 3z is equal to 0, 15z is equal to 0. So, 15z is equal to 0 implies z is equal to 0. Substituting in equation 2, we get y is equal to 0. Then substituting in equation 1, we get x plus 0 is equal to 0. Therefore, x is equal to 0. So, here we get, therefore, x is equal to 0, y is equal to 0 and z is equal to 0 is the unique solution, trivial solution of the given set of equations. 2x plus 3y minus z is equal to 0, x minus y minus 2z is equal to 0 and 3x plus y plus 3z is equal to 0. The second question is, determine the value of lambda for which x plus y plus 3z is equal to 0, 4x plus 3y plus lambda z is equal to 0, 2x plus y plus 2z is equal to 0 has a unique solution and a non-trivial solution. Now, we are going to write the given equation in matrix form. So, writing in matrix form, we get 1, 1, 3, 4, 3 lambda, 2, 1, 2 into x, y, z is equal to 0, 0, 0. Therefore, the augment matrix AB is equal to 1, 1, 3, 0, 4, 3, lambda 0, 2, 1, 2, 0. To solve this equation, we are supposed to write this in echelon form. So, the next step is using elementary transformation. We are going to reduce the rows. So, R1 is as it is 1, 1, 3, 0. R2 is equal to R2 minus 4R1. So here 4 minus, this place will be 4, 4, 12, 0. So 4 minus 4, 0. 3 minus 4 minus 1. Lambda minus 12, 0. So the next step is to make the third row first element to be 0. So your R3 is equal to R3 minus 2R1. So you are going to multiply the first row by 2. So here you get 2, 2, 6, 0. So 2 minus 2 gives you 0. 1 minus 2 gives you minus 1. 2 minus 6 gives you 8. 2 minus 6 will give you minus 4. 0 minus 0 gives you 0. So the next our aim is to make the second element of the third row to be 0. So write the first two rows as it is. We get 1, 1, 3, 0, 0 minus 1, lambda minus 12, 0. Now for third row, see, subtract one from the other. R3 is equal to R3 minus R3 is equal to R3 minus R2. See, R3 minus R2 gives you 0 minus 0, 0. Minus 1 minus 1, 0. So 0, 0. Then minus 4 minus 4 minus lambda minus 12. Then 0 minus 0, 0. So this is equivalent to 1, 1, 3, 0. 0 minus 1, lambda minus 12, 0. 0, 0, minus 4 minus lambda plus 12. Plus 12 minus 4 gives you 8. 8 minus lambda and 0. Now, this is an echelon form. This is an echelon form. Therefore, A is equal to, you are going to get 1, 1, 3, 0 minus 1, lambda minus 12, 8, 0, 0, 8 minus lambda. Now, this rank of A will be equal to 3 if this lambda is not equal to 8. If lambda is not equal to 8, then we are going to have rank of A is equal to rank of AB is equal to 3, as there are 3 not 0 rows. If lambda is equal to 8, then this place will be 8 minus 8 will be equal to 0. Same way here also 8 minus 8, 0. We get only 2 non-zero rows. Therefore, rank of A is equal to rank of A comma B is equal to 2, which is less than n. Hence, there will be, in this case, there will be a unique solution. In this case, you will have non-trivial solution. So, therefore, here when there is 3 non-zeros, here it will be when lambda is not equal to 8, we get there are 3 non-zero rows. So we get, therefore we get unique solution. Here it is less than n, therefore there will be many solutions. There are many solutions, which implies they have non-trivial solutions. So when the ranks are equal, they get only one solution. On that case, you get a unique solution. When the ranks are equal, but it is less than the number of variables, less than n, then we get many solutions, that is non-trivial solution. The third question is, by using Gaussian elimination method, balance the chemical reaction equation C2H6 plus O2 gives H2O plus CO2. We are supposed to find out the constant x1, x2, x3, x4 to balance this given equation. So let us assume let x1, x2, x3, x4 be the constants such that x1 C2 H6 plus x2 O2 equal to x3 H2O plus x4 CO. So now in this equation, we are going to equate number of carbons, hydrogen and oxygen on either side. So here comparing the carbon, see here we have 2 carbon, so 2x1. This side how many carbons we have? Only 1 carbon. So this is equal to x4. Therefore 2x1 minus x4 is equal to 0 is the first equation. Next, if you are going to compare, say hydrogen. So comparing hydrogen, how do we get? Comparing hydrogen. See here how many hydrogens are there now? 6 hydrogen. So 6x1 and this side 2 hydrogen. So this is equal to 2x2, 2x3. Okay. So therefore we get 6x1 minus 2x3 is equal to 0. This is going to be a second equation. Next we are going to compare oxygen. So compare oxygen. Comparing oxygen. How many oxygens are here? No oxygen. Here there are 2 oxygen. So 2x2 is equal to, this side you have 1 oxygen. So x3 and here you have what is here 2. So here you have 2 oxygen. So you get 2x4. So this equation, therefore we get this equation as 2x2 minus x3 minus 2x4 is equal to 0. Now we are going to eliminate the variables x1, x2, x3, x4, writing in matrix form. Writing this equation in matrix form, we are going to solve for x1, x2, x3 and x4. Now writing in matrix form, this is going to be, see, you have x1 is first equation, x1 is 2, second x2 is 0, x3 is also 0, x4 is minus 1. Second equation 6x1, no x2, minus 2x3 and then 0. Your third equation gives you 2x2, so there is no x1 here, 2x2 minus 1x3, then minus 2x4. So now we are going to write this in echelon form. So writing in augment matrix. Write matrix A comma B is equal to 2 0 0 minus 1 0, 6 0 minus 2 0 0, 0 2 minus 1 minus 2 0. So now using elementary transformation, we are going to write this in echelon form. So to write this in echelon form, so 2 0 0 minus 1 0. So we can write R2 as R2 minus 3R1. So multiply this by 3, you get 6 0 0 minus 3 0. So 6 minus 6 gives you 0, 0, minus 2 minus 0 gives you minus 2, 0 minus of minus 3 gives you plus 3, then 0 minus 0, 0. In the last row you get 0, 2, minus 1, minus 1, minus 2, 0. Next our aim is to make the second element of the last row to be 0. So this is equivalent to 2 0 0 minus 1 0, 0 0 0 minus 2 3 0. So to make this place a 0, we can rearrange this row. Instead of writing R, we can write here this R3 to R2 and R3 to R1, so we get it in echelon form. So the second row is going to be 0 2 minus 1 minus 2 0. See here your R2 is going to R3 and R3 is going to R2. So when we interchange these two rows, here you get 0 0 minus 2 3 0. So this is an echelon form. Therefore, this is an echelon form. Now this matrix is an echelon form. See, there are 4 variables. See now here rank of AB is equal to, rank of A is equal to, there are 3 non-zero rows, therefore this must be equal to 3, as there are 3 non-zero rows. But there are 4 variables, x1, x2, x3, x4. So this rank of AB is equal to rank of A is equal to 3 is less than n. Hence, the equations are consistent and have many solutions. Therefore, writing in equation form. We get assuming x4 is equal to t. Substitute in the first equation from 1, 2x1 minus t is equal to 0 gives you 2x1 is equal to t, x1 is equal to t by 2. Now we can substitute in equation 3. Substituting from 3, the third equation is minus 2x3 plus 3x4 is equal to 0. Minus 2x3 plus x4 value we are assuming it to be t. x4 is equal to t. So substitute 3t is equal to 0. So 2x3 is equal to, we take this minus 2x3 equal to minus 3 by 2t. So x3 is equal to 3 by 2t. Now substitute this value in equation 2. You get, from equation 2, we get 2x2 minus x3 minus 2x4 is equal to 0. So taking LCM, 2x2 is equal to minus, take LCM, you get here 4 minus 7 by 2t is equal to 0. So 2x2 is equal to 7 by 2t. Therefore x2 is equal to 7 by 4t. Now this t is a constant, t is a positive constant. So if we assume t is equal to some 4t, we get all these values as whole values as t is positive. Let us assume that t is equal to 4t. So we are going to get here x1 is equal to, your x1 value is going to be 2t. 4t divided by 2, it is going to be 2t. Your x2 is equal to, your x2 value you have 7 by 4t. So 7 by 4 into 4t. So this gets cancelled, you are going to get 7t. Your x3 value is going to be, x3 is equal to 3 by 2t. So 3 by 2 into 4t, this is equal to 2. So this is going to be 6t. Then x4 is equal to t. So substituting the values of x1, x2, x3, x4 in the given equation, x1 C2H6, x2 O2 plus x3 H2O plus x4 CO2. Here we get x1 value is 2t C2H6. Now you are going H6 plus x2 value 70 O2 equal to 6 H2O plus TCO2. Now cancelling T throughout, we get 2C2H6 plus 7O2 is equal to H6 H2O plus CO2.